Hello everyone, this is Mathematics and we are here with the second and fifth sections of the fourth chapter. So we're going to talk about reciprocal graphs and transformations. Well, to be honest, I forgot to mention two transformations, or let's say one type of transformations, which is reflections. And I'm going to mention them here in this session. And then we're gonna move to reciprocal graphs and then having some combination with reciprocal graphs and transformations, and you will see how that works. So let's get into work. As for reflections, so guys, the graph of y is equal to minus f of x represents the graph of y is equal to f of x with reflection into the x-axis, right? And the graph of y is equal to f of minus x represents the graph of y is equal to f of x with reflection into the y-axis. So, a type of mnemonic that I can give you for this is to say that minus y is equal to f of x, because I can move this minus here, right? If I multiply both sides by minus 1, or if I divide both sides by minus 1, doesn't matter. The equation becomes minus y is equal to f of x, right? And then here you have y is equal to f of minus x. Then you see that if the y is being affected by the minus, or let's say if the y is being inverted, then it is going to be a reflection into the x-axis. But if the x is going to be inverted or negated, doesn't matter, then it is going to be a reflection into the y-axis. So, y being affected, reflection into the x-axis. X being affected, reflection into the y-axis. So, I don't really use these mnemonics, but I just try to find a mnemonic for you to make it easy, if that makes anything easier. So, as for reciprocal graphs, finally we got to reciprocal graphs. So, reciprocal graphs are important, guys. How do I say they're important? Because you're gonna have a sketch in your exam, and this sketch is going to be either a cubic graph or a reciprocal graph. Alright? It's going to be either one of these two. So, you really need to know the four basic graphs of reciprocals, which are here, and you need to know them for your pure mathematics 1 exam, and to be able to sketch the other graphs of this kind. So, let's just review them very quickly. So, you see that, guys, if I have 1 over 10, let's say y is equal to 1 over 10, okay? And then I have y is equal to 1 over 0.1. Which one is going to be greater? Of course this one, right? Here y is going to be equal to 10, however here y is equal to 1 over 10. So, as x increases, y is going to decrease, alright? So the graph becomes like this. See? This will be your graph. Here, x is reaching its minimum. However, y is reaching its maximum. And here, while x is reaching its maximum, y is reaching its minimum. So you see the logic here, right? If I put two numbers here and then you compare them, you see that this makes sense, right? And this is it for this one. And while x is positive, then y is going to be positive as well. So x positive, y positive. When x is negative, then y is going to be negative as well. So x negative, y negative. Alright? And this is going to be our graph. Okay, why doesn't this one get erased? Right. So this is going to be our graph for first quadrant and the third quadrant. As for y is equal to 1 over x. And wait, why did this one get deleted? Okay, I'm gonna write it again. Y is equal to minus 1 over x. Guys, as for y is equal to minus 1 over x, you will see that while x is positive, then y is going to be negative, right? So x positive, y negative. However, if x is negative, wait, what is this one? While x is negative, then y is going to be positive. So x negative, y positive. And this will be your graph. As for y is equal to 1 over x squared, guys, as long as x is a real number, x squared is going to be greater than or equal to 0, right? So we know that while x is a non-zero variable, then x squared is going to always be positive, right? So if x is negative, or it is positive, or let's say it is not 0, then x squared is going to be positive always. So as long as x is positive, right, y is going to be positive as well. But when x is negative, no, it doesn't change anything. Y is going to be positive as well, right? So x squared positive, y positive, right? And x negative, again, y positive. So as for y is equal to minus 1 over x squared, so we said that if x is positive or negative, then x squared is going to be greater than 0. However, if it is being negated by this little minus here, then y is going to be negated as well. So while x is positive, y is going to be negative. And while x is negative, then y is going to be negative as well, right? So x positive, y negative. X negative, again y negative, right? And this is for it. Now, about reciprocal graphs. Guys, in your sketch of reciprocal graphs, in the exam, in your mocks, in your topicals, whatever, doesn't matter. Two things need to be mentioned. Okay, while I was erasing some things, this bullet point got erased as well. So, two things must be mentioned in your sketch. First, points of intersection with the x-axis and the y-axis, right? This is the first one. And the second one, equations of the vertical and horizontal asymptotes. Wait, what? Asymptotes? Wait, what are asymptotes? Alright, I wrote the definition of an asymptote here. So, asymptote, the line that the graph never reaches, or let's say the graph never touches nor intersects. So, what does that really mean? So, let's go back to our 4 basic graphs. Guys, you see that in this graph, let's say the first one, 1 over x, you see that this first section is not going to touch y is equal to 0, nor x is equal to 0. So, x is equal to 0 is this line, right? And y is equal to 0 is this line. And my graph is never going to touch these two lines. So these two lines are going to be my asymptotes. Y is equal to 0 is horizontal, so it's going to be my horizontal asymptote. And x is equal to 0 is vertical, so it's going to be my vertical asymptote. And for all of these 4 graphs, for all of these 4 basic graphs, the asymptotes are the same, alright? And we're going to deal with the transformations of these asymptotes, or let's say the equations of these asymptotes changing, and we're gonna have these different in our examples, and as it's going to be in your exam. So let's do some examples, right? So sketch the graph of equation y is equal to 1 over x minus 1. So I'm gonna look into the intersection points first. So for y-intercept, I know that for y-intercept my x is going to be equal to 0. So I'll have y is equal to 1 over 0 minus 1, which is going to be minus 1. This is for y-intercept. For x-intercept, I know that my y is going to be equal to 0 now, right? So I have 0 equal to 1 over x minus 1. I multiply both sides by x minus 1, and I'll have 0 equal to 1. How is that even possible? 0 is being equal to 1? This is not even possible. Right, this is not possible. So that means you have no x-intercept. No x-intercept. This is for this one. And as for your vertical asymptote, guys, see, as for your vertical asymptote, you have to, for every graph of this kind, you have to put your denominator, alright? Listen, you have to put your denominator equal to 0, alright? So, the denominator of the equation must be equal to 0, so must be equated to 0, not really being equal to 0. If it is equal to 0, then it is undefined. So we have our asymptote. So x minus 1 here is going to be equal to 0. So x minus 1 equal to 0. So x is equal to 1. Right? Not a good x, not a good one. Alright, not the best one, but a good one. So x is going to be equal to 1. So this is the equation of my vertical asymptote. And what about my horizontal asymptote? It's going to remain the same. Why? I will tell you later. Not here. Y is equal to 0. So you may say that what is the relation? What is the link between the reciprocal graphs and transformations? Here, guys, if I say that my f of x is 1 over x, then 1 over x minus 1 is going to be f of x minus 1, right? And we know that the equation f of x minus 1, the sketch of f of x minus 1, will be the same as the sketch of f of x, but moved 1 unit to the right. So this is how it's linked to transformations. And you can just imagine 1 over x, the graph of 1 over x, and move it 1 unit to the right and see that if your graph, your sketch is going to be right or not. So as for sketching this graph, okay, good, y, x. And you'll have, okay, minus 1 here, intersection points, y-intercept. Here, x is equal to 1. And then I know that my graph is going to be like this, right? Not really. This one. So this is my basic graph, right? This is my basic graph. So as we needed to remember, now we're going to sketch it, right? And as for this one, this is it. And y is equal to 0. So this is my sketch for part A. Let's move to part B. So 3 over 5x minus 2. So guys, if I so no, really, I'm just going to do the intersection points first. So for y-intercept, x is equal to 0, so y is going to be 3 over 5 times 0 minus 2, which is going to be minus 3 over 2. Right? And as for my x-intercept, my y is going to be equal to 0, so 0 is going to be equal to 3 over 5x minus 2. If I multiply both sides by 5x minus 2, then I'll have 0 equal to 3, which is not true. So, no x-intercept. Right. And as for my vertical asymptote, I said that for the vertical asymptote, we need to equate the denominator to 0. So 5x minus 2 equal to 0. So x equal to 2 over 5. And as for my horizontal asymptote, again, it remains y is equal to 0. Why? Again, I will tell you later. So if I want to sketch my graph, let's move this one a little bit here and drag this one down here. Okay, so I'm going to sketch my graph here. Now that I have a space, I will draw it much better. Not really, my drawing is not good. So okay, so y, x. And I had my y-intercept at minus 3 over 2. right? And I have my vertical asymptote at x is equal to 2 over 5, right? So my basic graph is this one, right? So I'll sketch my graph as here, wait, here and here. See, this is it. This is the sketch for part B. And we get to part C. All right, let's solve part C. As for y-intercept, x is going to be equal to 0, so my y is going to be equal to minus 3 over 4 plus 6. So minus 3 over 4 plus 6 is going to be equal to 21 over 4. All right, this is my y-intercept, right? As for my x-intercept, I'm gonna put y equal to 0. Therefore, minus 3 over 3x plus 4 plus 6 is equal to 0. So minus 3 over 3x plus 4 is going to be equal to minus 6. So minus 18x minus 24 is going to be equal to minus 3. And so minus 18x is going to be equal to 21. So x is going to be equal to 21 divided by 18 minus 7 over 6. Right? And this is going to be my x-intercept. And now, as for your vertical asymptote, the denominator must be equated to 0. So 3x plus 4 equal to 0. So x is equal to minus 4 over 3. What about the horizontal asymptote? Guys, horizontal asymptote is now y is equal to 6. See, what is the difference? Guys, when you have a constant term, after your reciprocal, that is going to be your horizontal asymptote. So if this was minus 5, then my horizontal asymptote was y is equal to minus 5. If it was minus 2, then my horizontal asymptote would have been y is equal to minus 2. So this is how it works, all right? This is plus 6. Let us not forget. And I'm going to drag this one down again. Wait, where did it go? Right here. So I'm going to sketch the graph here in this page. Okay, and this one, y, x. So, where do I start from? My y-intercept, 21 over 4. Right? Then I'll have my x-intercept, which is, where is it? Oh, minus 7 over 6. Minus 7 over 6. Then I'm gonna have my vertical asymptote, which is minus 4 over 3. Okay, is minus 4 over 3 before minus 7 over 6 or after minus 7 over 6? Let us see. Which one is closer to 0? Minus 4 over 3 or minus 7 over 6? If I multiply this denominator and numerator by 2, then it is going to be minus 8 over 6, right? Then minus 8 over 6 is farther away from the origin than minus 7 over 6. So it is going to be minus 4 over 3 here, right? And wait a minute, all right. This is going to be my vertical asymptote, which is x is equal to minus 4 over 3. And therefore, I have my horizontal asymptote. Y is equal to 6. Okay, which one's greater? 21 over 4 or 6? Of course 6. So 6 is going to be above 21 over 4. And I'll have my horizontal asymptote as y is equal to 6. So if I want to sketch my graph, guys, I know that among my basic graphs, you see this is going to be this one, right? Why? Because the coefficient here is minus. Okay, it is negative. So my graph is going to be something like this one. here, and here. This is my graph for this part. All right, this is my sketch. And then we'll have our part D, okay? Wait, I had enough space. Why did I move it? Okay, no worries. Let me just... Okay. So, again, y-intercept. X is going to be equal to 0. So, y is going to be equal to minus 2 over minus 1 squared, which is going to be 1, plus 2. So, it is going to be 0. The origin. Oh, very nice. So, wait, how do I know it is origin? Let's continue. X-intercept. Y is going to be equal to 0. So, I'll have minus 2 over x minus 1 squared plus 2 equal to 0. So, I'll have minus 2 over x minus 1 squared equal to minus 2. So, I'll have minus 2 times x squared minus 2. Wait, what is happening here? Alright. Okay, my pen. Okay, x squared minus 2x plus 1 is going to be equal to minus 2. So, minus 2x squared plus 4x minus 4 is going to be equal to... Guys, my pen is annoying me. Minus 4 is going to be equal to minus 2. So, minus 2x squared. Okay, wait, this is 1. Why did I read? Nah. So, minus 2, these two are going to cancel out. Minus 2x squared plus 4x is going to be equal to 0. So, if I factor out minus 2, then it is going to be x squared minus 2x equal to 0. So, x is going to be equal to... so, I'll have x times x minus 2 equal to 0. So, I'll have x equal to 0 and x equal to 2. So, these two are my x-intercepts, guys. So, you see, x is equal to 0. Well, passing through the origin, right? This is it. And if I put x equal to 2 here, what is going to happen? So, if I put x is equal to 2 here, 2 minus 1 squared is going to be 1, right? Minus 2 divided by 1 is going to be minus 2. Minus 2 plus 2, again, it is 0. So, my intersection points are going to be 0 and 0 as well as 2 and 0, right? And then I have my vertical asymptote. For vertical asymptote, we were supposed to put the denominator equal to 0. So x minus 1 squared equal to 0. All right. So x is going to be equal to 1. Right? This is my vertical asymptote. As for my horizontal asymptote, I said whatever constant that there is after the reciprocal. What is the constant? Plus 2. So, it's going to be y is going to be equal to positive 2. So, as for my sketch, I have everything here, so I can sketch the graph now. Right, y, x. And then it is going to be x equal to 1, my asymptote, my vertical asymptote. Y is equal to 2, my horizontal asymptote. Okay. And then I'll have 0 and 0. Okay, one intersection point here. And 2 and 0. So one intersection point here, which is 2 here. And then I'm gonna find out the shape of my graph, right? It is in the form minus 1 over x squared. So it's going to be both downwards, right? This was my fourth basic graph. And it is going to be something like this. And this is my sketch for part D. And guys, with this, Chapter 4 is finished, and we are going to start Chapter 5 from next session, the equation of straight lines. So, till the next session, see you and take care.